Alright, so here's a system that is nonlinear in nature, and there's two types that we can deal with. Ones that we can do elimination with, and other ones we'll have to do substitution with. This one is set up for elimination because you have two x squares and two y squares. Substitution comes in handy when the variables don't match up so nicely. Alright, so this one's pretty simplistic. All we have to do is add the two systems together. The y squares will cancel, and we just have to solve for x squared. Now over here are the two graphs. This one is the x squared over 4 minus y squared equals 1. It's called a hyperbola. The top one obviously is a circle with a radius of 3 centered at the origin, so that's this graph. And notice they intersect at 4 different locations. So what we're looking for is 4 answers, and mathematically it should pop out rather nicely, even if you don't know what the picture looks like. So let's take these two, add them together, and see what happens. So if I add these all together, the y squares are going to cancel. The 9 plus 1 is going to become 10. And on this side, you're going to get 4/4 plus 1/4, better known as 5/4 x squared. Alright, and then just solve the equation like we've been doing all semester long. So let's multiply both sides by 4/5, the multiplicative inverse. And that should give us a nice little equation. X squared equals 8. Now, to solve this, going back a bit, we'd have to square root both sides of the equation. And you have to remember that anytime you square root both sides of the equation, you have to add in a plus or minus. So you get x equals plus or minus 2 square roots of 2, which is the reduction of square root of 8. So this gives us two x values. Now, the two x values, there's this one over here, which is positive 2 square roots of 2, and the one over here, which will be negative 2 square roots of 2. So to find the y value, we just have to take this and plug it into one of the equations. It really doesn't matter which one you plug it into. So I'm going to plug it into the bottom one. And the way I'm going to plug it in the bottom one is, the first thing I'm going to do is get y squared by itself. So I'm going to move the y squared and the 1 back and forth. So I'm going to generate this equation. Y squared is equal to x squared over 4 minus 1. Because the y squared will become positive, the 1 will become negative. And then when we square root both sides, we're going to get y is equal to, and don't forget, plus or minus the square root of x squared over 4 minus 1. Alright, and now we can substitute in our two values. So the first one we're going to substitute in, and I'm going to use some fancy notation. We're going to let x equal positive 2 square roots of 2. So this basically just means evaluate when x is equal to 2 square roots of 2. So we're going to get y is equal to plus or minus the square root of, and when we square the square root of 2 square roots of 2 is the same thing as squaring the square root of 8, which just makes this x squared 8. So we're going to get 8 over 4, which is 2, minus 1, and we get a y value of plus or minus 1. Alright, let's do the same thing for negative 2 square roots of 2. Oops, sorry. We really don't need the square anymore. We got plus or minus the square root of. Now, when we plug in negative 2 square roots of 2 and square it, we're going to get a positive 8 again, so the answer is going to come out exactly the same. So we're going to get y equals plus or minus 1. So over here, when we evaluated for positive 2 square roots of 2, we got two answers for the y. So that gives me two coordinates. My x-coordinate of 2 square roots of 2, comma, y being positive 1. My coordinate, x-coordinate, being 2 square roots of 2, my y being negative 1. Then over here, I have x equal negative 2 square roots of 2. And when I shoved that in there, I got y was equal to positive 1. And I got y is equal to negative 1. So here are the four coordinates where these two graphs run into each other. So this is a system of equations by elimination.